So let's say we've got this triangle here. We've got a right angle triangle. We know that one of the angles is 29 degrees. The hypotenuse is 15. And we've got another side that we want to find the height of. So because this is our angle 29 degrees, this side here, where the 15 is always the hypotenuse because the right angle points to it. And over here we have the opposite side. Because we've got opposite and hypotenuse, remembering SOHCAHTOA, we have to use sine. So we start with sine of the angle, so that's 29 degrees, has to equal opposite over hypotenuse. That's a very important first step. That shows your understanding of sine, cos and tan. Now from there, we have to find out what x is. It's just like with equations. We don't want to divide by 15, so the opposite is timesing by 15. Whatever you do to one side, you do to the other. The 15s cancel, and you're left with x equals 15 times sine 29 degrees. On your calculator, making sure that it's in degree mode, so there should be a little D on your screen, not an R or a G, otherwise you have to change the mode. You'll type in 15 times sine 29 and you'll get 7.2721443. But if I want to figure out what my answer is, say to one decimal place, I want it to end after the 2 or at the 2. So the 7 is bigger than halfway, so my answer will be 7.3. If the question was in metres, say for example the 15 was 15 metres, then my answer would be 7.3 metres. So using right angle trigonometry, we can find out the side length of any of the sides of the triangle, or we could find out what the angle is as well. With this triangle, we've still got a right angle triangle. My angle is 21 degrees and I've got two sides. Which sides are they? This one over here, the right angle points to it, so it's the hypotenuse. This side is next to the angle, so it's called adjacent. So thinking of SOHCAHTOA, SOHCAHTOA, which one uses A and the H? There they are there. So we're going to use cos. So we always start with cos of the angle equals adjacent over hypotenuse. From there, it's an equation. We want x by itself. At the moment, it's been divided by 8, so we do the opposite and times by 8. Whatever you do to one side, you do to the other. The 8's cancel, so you're left with x equals 8 times cos 21. Putting that in your calculator, you get 7.4686434. If we wanted that, say, to two decimal places, I want it to end there. The 8 is bigger than halfway, so it goes to 7.47. If this question was in metres, if that was 8 metres, then x would be 7.47 metres. With this triangle, we've got a 60-degree angle, and opposite that 60-degree angle we have 12, so that's opposite. And this side down here is next to the angle, so it's called adjacent. Which ratio uses O and A? It is tan, because of SOHCAHTOA. So we start off, tan of the angle equals opposite over adjacent. Now this one's a little bit tricky because the thing you don't know is on the bottom. So to get rid of the x on the bottom, we times both sides by x. So then we have x times tan 60 equals, those x's cancel, equals 12. But we still haven't got x by itself. At the moment it's been times by tan of 60. The opposite of timesing by tan of 60 is dividing by tan of 60. Once again, I have to do it to the other side as well. Those two cancel, So I'm just left with my x equals 12 of tan of 60. And plugging that into your calculator, you get 6.9282. And you could round that off roughly to 7 to the nearest whole number. Now, with this one, if you have a look at what's happened with the x and the tan 60, these two, and when we did our 2 steps of working out, if you have a look at what's happened, they've actually swapped places. So a shortcut for that could be, if you have that first step, which is tan 60 equals 12 over x, then those two end up swapping places. So you end up with x over 12 of tan 60. But you can only do that when you've got x on the bottom, not on the top. The other thing we can use right angled triangles for is to find an angle. But we still start exactly the same way. Here I have the hypotenuse. And over here I have the opposite side. So I still start off with opposite over hypotenuse, which is sine. So it's the sine of the angle equals the opposite side over the hypotenuse. Now, the only way we can separate the sine with the theta is by using the shift key on your calculator. So, what theta is going to equal is shift sine. So we need to press the shift button, shift sine on your calculator, and then your 7/12. When you press equals for that one, you end up with 35.68533471. But if we want degrees and minutes, there's a bubble button. It looks like something like that. If you press that, that will tell you your answer in degrees, minutes and seconds. So you get 35 degrees, 41 minutes and 7.2 seconds. We don't normally have to go to that level of accuracy. So if we went to the nearest minute, it would be 35 degrees and 41 minutes, because this 7.2 is actually quite small. When rounding off degrees, you have to be careful because there are 60 minutes in a degree, so halfway is 30. So in this question, if we wanted to round off to the nearest degree instead, from that line, theta would equal not 35 degrees but 36 degrees, because the 41 is bigger than halfway, because halfway is 30. So it's 36 degrees to the nearest degree, but 35 degrees 41 to the nearest minute. So this one here is the nearest degree. And one last thing with trigonometry is angle of elevation and angle of depression. If you've got a horizontal line and then you look up, then that angle in there, so if you look up along that line, that angle is called the angle of elevation. But if you've got a horizontal line and you look down, then that angle is called the angle of depression. Now these words are used quite a lot in problem solving. If you've got the angle of elevation of a boat up to a cliff, or the angle of depression from a plane down to the tower at the airport, then you have to know what these words mean. But we'll always need a right angled triangle in these sort of situations. If I have a boat, okay, and the boat has an angle of elevation up to the top of a cliff, and that angle of elevation is 37 degrees. That angle is from the horizontal going up. If I have another diagram where I've still got a cliff, and from the edge of the cliff, the angle of depression down to the boat, say, is 57 degrees. So that means we start with the horizontal and our angle of depression, so going down, our angle of depression is 57 degrees. Okay, so angle of elevation starts with the horizontal and goes up. Angle of depression starts with the horizontal and goes down. Now you also have to remember in cases like this, let's finish off my right angle triangle, is these lines are both horizontal, which means they are parallel. And in parallel lines, this angle is exactly the same as that angle. They are called alternate angles and they are equal when the lines are parallel. So that information will probably be useful when working out questions using angle of depression.